Hi, I'm David, founder and CEO of Neura Robotics. Let's say AI model behind. So what you see here is actually when the robot actually gives me like something, it's like supernatural. So it means when it takes, like as soon as it sees, actually takes it, and then when you put your hand there, it will actually also notice it and actually react on it. What you see here is basically the way how we train this robot. Or you can go in our gyms, that's how we call them, it's like a gym cell, and you basically take one of the suits and then simply remote control the robot and do a task. And then what you do is actually you're fine-tuning the foundation model, which is a perception language action model, a multimodal version of it. Partner with some large manufacturing companies where we have more than 1,000 humans actually in data suits and get streaming also this data out. So it's a mixture of direct data out of robots, what you see here, and also the mixture of human data like tactile sensors and audio sensors, and then also like basically simulations, like you're amplifying basically the data. So you have like, let's say 5 times how you grasp it, and then you're basically, at the same time you're running also a digital model, it's a digital twin. And with this, you're actually using reinforcement learning to have, let's say, multi-grasping while you're only grasp once. They're like a data set of grasping it 100 times. And we have all kind of form factor. The similarity between all of them, they all have the same sensors, so hearing, seeing, and feeling. They're using the same brain. Please grasp Apple. What you do is actually now, just with the talk I just had, it actually starts generating the whole skill set. So it takes all the skills it has together and generates basically a whole pick of the apple. And the cool thing is, like you can also see how it works. It's a node graph editor. It's actually where you connect all these devices to each other. Or so here, this is how it looks like in the background. First runs actually anyways a simulation behind, if it's possible. And that's also what you see now. As soon everything is initialized, it will actually go and actually grasp also the apple. But this is all orchestrated actually with the model. Or so you're basically interacting now in a fully, let's say, flexible environment. And this is basically all done by our platforms like a ChatGPT, but for real world physical AI. So you have basically also here, it's like the same, the orchestrated basically digital twin. See also here that the robot is right now in the initial phase. So you can basically see every of the devices around here, what they do, how they move. It's also in real time. They're all connected. And you see actually also robot difficult goods like bottles, and in this case like bottles of wine. So what it does, it's still, in my opinion, a little slow, but at least it does it, and does it actually pretty careful in a pretty good way. So it puts actually the bottles into the shelf and understanding actually like the environment. Or so it's also like this a MIPA version. So it's not a humanoid, but it's actually 2 arms on a mobile platform, basically on wheels. So it just places right now the one bottle, and then it's placed the hearing, seeing, feeling, always the same. It's a PLA, we call. PLA is a perception language action model. So you can also just like basically interact with it. Like, so you can let it walk, or like you just can gesture and then it walks towards, you can actually stop it and then stop. So, and you can also like, it's pretty robust also. So you try to, like it's all, you see also like the full body, it's under control. We developed that one for research mainly. So it's like that you can actually access to it. It's the same actually model behind, it's the same platform you're aware. So you can simply remote control it, you can train it, but actually not do all the things the other can do, because it still has some gap in the sensorization. You see also here, like all devices are actually connected to Neura's platform, and you can simply interact with it. So see that it does basically also like a phone, but it's actually interconnected in the same platform as the humanoids are. So they're all in one brain, using one brain, interacting with environments. Or we have a lot of partnerships where we partner with the core, let's say, existing robot players worldwide, and they're actually, let's say, even using our technologies in combination with theirs in the world already. So that's also how we sold already thousands of devices into the market. It's simply because we use actually here the partnership approach. We do not believe we can do everything ourselves, because we think they have already let's say established channels, and that's actually how we collaborate. And that's why also I would say it's a part of our success story. Building pretty good robots and others actually having use of it, at the same time using their knowledge on our platform. What you see here is basically the Gen 3.5. It's the version actually which came after the Gen 3 we just saw. It's actually 3.5 because there's now a 4 coming out. But here you see actually it's the same approach. It's a multimodal actually sensor approach. Here the difference here is actually not just the brain but also nervous system implemented. So it has like a strong GPU but also a very strong nervous system built. That's why perception language action models, like it's not just the brain, it's also reactive. That's what you see there on the hands. That's what we have now here also on the eyes and the ears. So it's a pretty good thing. So that's how they look basically inside. Or every of the systems basically is just a cover what you see above. But normally we didn't try it. It's the older version. That's why we're showing it. And you basically see also like their build actually to be robust and stay around. But this is actually trained in this should be like a standard, though. Like all of them are robust, walking around. But what we focus right now on is mainly the multimodal version, like for the hands and fingers. How do you interact with the physical world? We have a lot of partnerships in that space. And this year it's a couple of hundreds we deploy in real factories. We deploy about 2,000 in the gyms this year, several hundreds basically in real production lines. That's also our core focus now, and that's actually also I think like this funding round is reflected in our. So it's mainly like deploying as many as possible and building the infrastructure so everyone can train these robots in a very fast way. Yes, we don't try to collect just data. We try actually let everyone train their own skills. So that's a difference from us to others, that we don't want to know everything others know. We want to enable everyone to actually train the robot in record time on any kind of task. This is actually here a difference. They're made for just working. So everything you have here is like made to actually be as robust as possible. And there's also here, it's like a water-cooled compute unit. It has so many changes out of the real-world experience we made. They're not just awesome, you know, we have a lot of pain, but you see actually now like the huge progress in that space. So it's so huge, or so it's like every time now. That's why we were here already with a go-to-market approach. Like we started to produce them and figured out that they're not good enough and already coming. That's why we are talking already about Gen 4. It's the next generation. It's again slimmer, much better, and actually much more reactive, and it has already the full nervous system in place. Again, sensorization, compute infrastructure. That's the biggest difference. I mean, the actuators and whatever, we just made it a little slimmer again, a little bit more effective, but core difference is again, the sensorization on the fingers. It's again like the compute infrastructure, how we compute, or like what's the nervous system and what's the brain part. Be aware like that robotics comes faster than everyone thinks. I think right now we're like in a moment, like everyone talks about ChatGPT moment, or now is the moment where ChatGPT just answered your hello back and said like, hey, how are you? So, but I think in the next couple of, let's say, month, you will see already really doing real tasks. And then looking forward, I think next 1-2 years, it will be the biggest breakthroughs in robotics. And they will actually, and to the other part, we have to be aware and we have to prepare for one thing, is that robots will take over every physical task. It will not be just a part of it, because it will not make sense to actually use humans for that, because they will train faster for everything. So that's the short message. Don't be scared. Let's enjoy this actually journey together and actually transformation of humanity.